Alright, ladies and gentlemen, we are going to multiply and divide complex numbers or numbers with imaginary numbers. And this is Mark Anderson for Keller Community College to run through this second of three-part video to talk about complex numbers and what we do with the number I or the square root of a negative 1. Now, it's important to note that since we're going to be multiplying complex numbers, the property of x times x would make x squared. So I times I would also have the I squared property. But I squared is actually kind of a cool thing, because if we take the look at I, which is going to be the square root of negative 1 by definition, I squared would be the square of the square root of negative 1 or negative 1. So to cut to the chase, anytime you see I squared, that's the same as negative 1. Because I is the square root of negative 1, so squaring it would give you just negative 1. Which brings this problem into focus, because 5 times negative 8 is negative 40, and I times I is I squared. And if we have I squared is the same as negative 1, so that's negative 40 times negative 1, or 40. That is the answer to the first problem. Here I'd have negative 4i times negative 8i, which is 32 I squared. And because I squared is negative 1, or 32 times negative 1, your answer is negative 32. So far so good, but look at this problem here. You might think that you want to multiply straight across and get a positive 48. Well, unfortunately that's not the case. In this case, this is the square root of 6i, because you can just pull the negative out of the radical by making it an I outside of the radical. This is going to be the square root of 8i. So what I now have is the square root of 48, I squared, or negative square root of 48, which I also need to simplify, because that 48 under the radical is divisible by 16. And if I divide it by 16, I get 3. So my final answer is negative 4 square roots of 3. Now, if you had just multiplied the negative 6 times the negative 8, and you would have gotten 48, your answer would have been positive 4 square roots of 3. But this is the way you have to process it. You can't just double negative your imaginary numbers out of the situation. You have to pull them out and process them, and then take care of the radical inside. Now, all of those seemed pretty straightforward except for the little trick in this problem here. But now what we're going to do is we're going to do a little bit of FOIL, or a little bit, in this case, distribution, before we hit the FOIL problem. This is 6i, and this is going to be plus 2i squared. And again, because I squared is the same thing as negative 1, this is 6i plus 2 times negative 1, or 6i minus 2. Now, what we should do is rewrite this as negative 2 plus 6i. Because most all the books that I've seen will have a plus bi format. In fact, if you push the mode key on your calculator, you will see that next to the real option there is an option to set your calculator in a plus bi form. So that actually would allow you to do some of these problems by just typing them into your calculator. But not all of them would come out correctly, especially this problem right here. On the calculator, this problem may not actually work if you even set it up into a plus bi format. But my whole point of talking about this is when you get to your answer fully simplified, you should put your rationals and irrational and imaginary in that order. You'll also feel that this kind of fits the quadratic formula format quite a bit. So for our last two problems here, before we start dividing rationals, we are going to look at this. Oh shoot, let me kind of scooch this up just a little bit more. All right, I want all of this here in my screen as I talk about this, because this is a FOIL problem where 3 times 3 is 9. 3 times the 5i is plus 15i. The negative 5i and the 3 is negative 15i. And the negative 5i times the positive 5i is negative, that's a negative, 25i squared. Now, when I start simplifying this FOIL problem, you'll notice that my O and my I cable simplify to 0, which leaves me with 9 minus the 25i squared. And the minus 25i squared is like minus 25 times negative 1. So it's 9 plus 25, because negative 25 times negative 1 is positive 25. So my answer is 34. Now what's really cool about this is that this problem here has absolutely no I left over. And this is a classic pattern of the difference of squares, kind of like x plus 3, x minus 3 is x squared minus 9. Well, we're going to use this trick down below here in these problems. In fact, these last two that you see on this page. So kind of keep this keep this in check here. Now what we're going to do is do some FOIL here. 5 times 2 is 10. 5 times I is 5i. 4i times 2 is 8i. And then 4i times I is 4i squared. Now that 10 is going to stay here. These are going to get added up to 13i, and that 4i squared becomes 4 times negative 1, or minus 4. Now I get to put the 10 and the negative 4 together to make 6 plus 13i, and I'm done with my answer because that is the correct format, 6 plus 13i, or radical, or rational, irrational, imaginary in that order. And that looks good to me. Now we're going to talk about dividing these complex numbers. Rationalizing the denominator. In a previous problem, in a previous section, we cannot leave this in the denominator. We have to multiply the numerator and denominator by the square root of 3. And what this will do, it'll give me a denominator that does not have a radical in it. Well, since the definition of I is the square root of a negative 1, this is technically a radical in the denominator. So just like we can't have radicals in the denominator, we cannot have I in the denominator. So to get rid of this, we'll just multiply top and bottom by I, and we get an answer of 6i over I squared, which is 6i over negative 1, because I squared is negative 1, which then I can simplify to 6i with a negative in front, because 6 divided by negative 1 is negative 6. So that is my answer to the problem. Here, I could multiply top and bottom by negative 2i, but in this case I'm just going to multiply top and bottom by I, because what that's going to do is give me 4i minus 6i squared all over negative 2i squared. And that negative 2i squared is going to fix that denominator right up. So 4i plus 6, you'll see that I just turned the negative 6i squared into positive 6, because that negative 6 times negative 1 is positive 6. And down below, the negative 2 times negative 1 is just going to be positive 2. Now I'm going to change my numerator order there so it fits my pattern of a plus bi, all divided by 2. And I'm going to split this up because I want to divide each of these by 2, and that's going to give me 3 plus 2i. And that, my friends, gives me the pattern that we need to see for anytime we have an I in the denominator. Just multiply top and bottom by I and you'll get rid of it. Now, what if I have a binomial that has an I? Well, I just can't multiply top and bottom by I because that will give the 3 an I. It won't actually get rid of it. So look back at this starred problem. You'll see that this binomial multiplied by this binomial got rid of all the i's. So we really need just a difference of a binomial to go down here. So this is going to be 3 minus i, 3 minus i. So 8 times 3 is 24. 8 times negative I is negative 8i. Down below, we do some foiling there. 3 times 3 is 9. 3 times negative I is negative 3i. I times 3 is positive 3i. And then I times negative I is negative I squared. Wow, so here's what we got. These simplify. 9 minus I squared is like saying 9 plus 1. And because negative I squared is like negative 1, so plus 1. So here's what we have. We have 24 minus 8i all over 10. And what I'm going to do is split that up so you can see how it simplifies. 24 divided by 10 is going to be simplified to, if I divide top and bottom by 2, gives me 12 fifths. And yes, 12 fifths. And then I'm going to say, I lost my place there, 8i divided by 10. So if I divide top and bottom by 2, that gives me 4i over 5. So my answer is 12 fifths minus 4 fifths I. And some of you might have written that as 12 minus 4i over 5, which would also be correct. But I like splitting the wheels up for the last problem that we do here, not on this page, but below it. You will see that splitting them up is going to be very useful to us. So I'm going to multiply this by 4 minus I, multiply this by 4 minus I, and I'm going to do some foiling in the top. That top's going to get foiled pretty much pretty quickly. So 3 times 4 is 12. 3 times negative I is negative 3I. 6I times 4 is 24I. Should look like a 24. And then the 6I times negative I is negative 6I squared. All over 4 plus I, 4 minus I. So this is going to be 16 minus 4I plus 4I. I love that. That's going to simplify. And this is going to be negative I squared. So, bam, bam, this makes 16 plus 1, so my denominator is going to be 17 in my, and I'm going to split up right now just because I know how it's going to go. Okay, so the 12 plus the 6i, no, so, I'm sorry, 12 plus the 6, because the negative 6i squared is just going to be positive 6, is going to give me 18, because 12 plus 6 is 18. And then the negative 3 plus the negative 24, or sorry, the negative 3i plus the 24i is going to give me 21i. And that, my friends, is the end of that problem because I can't divide by 17 in each situation. And I know some of you might have written this as 18 plus 21i divided by 17. That's fine too. I kind of like splitting these up because, like in the last two problems we'll do, after I scroll the page down here, you will see that doing that is going to give me a better and more reduced problem. So for our final two problems here, we are going to multiply top and bottom here by 2 minus I. And yeah, you could factor a 2 out of the numerator, but I doubt most of you would have done that. So let's just kind of plod through here and see what we get when we do our distribution. In our numerator, 4 times 2 is 8. 4 times I is 4I. 8I times 2 is going to be 16I. And then 8I times I is going to be 8I squared, all divided by this FOIL problem of 4 plus 2I minus 2I minus I squared. So what we have here in our numerator is going to be 8 minus 8, because that's what the 8I squared is going to be, and that simplifies to nothing. The 4I plus the 16I is 20I. Our denominator is going to be 4 minus I squared, or 4 plus 1, so 5. And so my simplified answer is going to be 4I. Yep, 20 divided by 5 is 4, and then 4I is my final answer there. Wow, that was pretty interesting. Now here, you would be probably better off by factoring out a 3 in this case, but, you know, I doubt some of you would have done that. You would just kind of move forward and go, say, 12 plus 6i over 12 plus 6i, which is completely doable. It's just your numbers get a little big, and then we have to do some simplification. If we do our distribution, what we have here is 36i in the numerator plus 18i squared in the numerator, all over this FOIL problem of 144 minus 70. Is it plus or minus? It is, so we got a minus plus here, so plus 72i minus 72i, that's our O and our I cable, and then minus 36i squared. Whoa, that is a denominator. Look at my numerator. Let's do some simplification. 36i, and then the 18i squared. Let's bring that in front as a negative 18, because I squared is negative 1. Now let's look at our denominator. These two go away. This is a positive 36 because negative 36i squared is a positive 36. So 144 plus 36 is 180. And this, my friends, is the main reason why we split this up. Because what I can do here is divide the top and bottom by 18, which gives me negative 1 over 10. Look at me kind of mess with that there. So again, dividing top and bottom by 18, negative 1/10. Now here, I'm going to divide the top and bottom by not 18, I'm going to divide it by 36. And what that gives me, it's going to give me plus 5, or sorry, just 1i, or just 1/5 I. And I could rewrite that as I over 5, but you know, I kind of like it this way. Dividing the top and bottom by 36 is 1 over 5. And so this is my final answer. And this is one time when splitting the wheels up. So if you had, you know, your negative 18 plus 36i over 180, you really don't get down to the fine simplification of it if you leave it all over 180, because you can't divide everything by 36. So I want to just show you that, and I want to say thank you very much for watching the video here. It's a little tough, but part 3 is going to come up soon, where we're going to be solving equations with complex solutions, which means that you're going to have square roots that have negatives in them and have i's in your answer. So thanks again for watching.